Take a moment to look at the objects right in front of you. Whether you are at your desk or in a classroom, your immediate environment is a collection of very different surfaces. Notice how the light reacts differently to each one. A metal paperclip catches the glare and sparkles, while the wooden pencil beside it looks completely flat. Look at the wall and the window. One allows you to see the trees and sky outside with perfect clarity, while the solid structure next to it blocks your view entirely. These differences exist because everything around you is made of a specific material. Each material possesses unique properties that dictate how it behaves and what it can be used for. By observing just two of these properties, how a surface looks and how it handles light, the engineering logic behind every object in the room begins to reveal itself. We start with luster, the scientific term for the shiny appearance of a material surface. Microscopically, luster is about smoothness. On a flat surface, light rays bounce off in parallel lines, reflecting a bright image. Non-lustrous materials are different. Their uneven surfaces cause incoming light rays to scatter in every direction, preventing a clear reflection. This is why metals like steel and aluminum are naturally lustrous. They naturally form those incredibly smooth, uniform surfaces. However, exposure to moisture or air can cause metals to tarnish. This chemical reaction creates a rough, oxidized layer on the surface, which scatters light and causes the material to lose its luster over time. When you polish that metal, you are physically removing the rough, tarnished layer. You are smoothing the surface back down to the bare metal, restoring its ability to reflect light. Remember, shine and color are not the same. This car is black but highly lustrous, while the yellow cloth is bright but completely matte. This also applies to hardness. While we can categorize materials as hard or soft, those traits don't determine luster. Soft things can be shiny, and hard things can be dull. A material's luster is simply a readout of its surface smoothness and metallic makeup, regardless of its color or how it feels to the touch. Now we shift from how light bounces off a material to what happens when light travels through it. Materials are transparent if they allow light to pass through them completely and cleanly. This provides a clear, undistorted view of whatever is on the other side. Translucent materials allow some light through, but they scatter the rays as they pass. This creates a blurry or obscured view where objects are visible only as shapes or shadows. Opaque materials block light entirely. They reflect or absorb the rays, making it impossible to see through them at all. You can see every detail of this person behind the glass because the material is transparent, letting the light reach the camera without interference. Behind frosted glass, the person becomes a silhouette. The translucent material scatters the light, losing the details even though the light itself gets through. Behind this wooden wall, the person is completely hidden. Because the wood is opaque, the light is blocked entirely. Keep in mind that opaque refers only to blocking light, not to color. This lunchbox is a bright, vibrant pink, yet it remains completely opaque. Mastering these categories gives us a powerful design tool, the ability to control exactly what is seen and what is hidden. To see how these properties work together, consider the design of a modern house. Transparent glass is the standard choice for living room windows. It allows maximum sunlight into the home and provides clear views of the environment outside. But for a bathroom, designers often choose translucent frosted glass. This property solves a specific problem. It lets in natural light while guaranteeing privacy for the people inside. For the exterior walls, opaque materials like Birks and wood are essential. They provide a sturdy structure that shields the interior from the outside world. Today, we have added 5 specific terms to our scientific vocabulary: lustrous, non-lustrous, transparent, translucent, and opaque. Take a look around you right now. Can you find and identify 3 different objects that fit these descriptions? Identifying these properties reveals the deliberate, invisible recipe behind every object we interact with in our daily lives.